Hi, and thanks for joining me today. My name is Jeff LaFavors of ClearlyAgile, and I'm here to present Measuring Success in DevOps Transformations. Now, you might be asking yourself, who is Jeff LaFavors? What is ClearlyAgile? And why should I listen to this guy? Well, funny you should ask. I have a slide for that. ClearlyAgile, or CA for short, is a consulting company, software consulting. We deliver custom software solutions with an Agile mindset. We're very much proponents of the Agile methodology. Our staff is made up of top-notch developers that are skilled in the latest and greatest technologies, but we also have some of the best Agile minds in Tampa, if not all of Florida. And as I mentioned to you, look at that picture. Obviously, pre-COVID era picture, dress shirt, which I probably haven't worn in a good 6 months. And I had a big smile on my face back then, but neither here nor there. As I mentioned, my name is Jeff LaFavors. I'm a managing partner at CA, and I've been a solution architect in the Tampa Bay area for over 10 years. I'm an Agile enthusiast myself. I'm a certified Scrum Master. I've been a proponent of Scrum specifically for over 10 years. For the last 10 years, I've had experience with various industries, including healthcare, oil and gas, finance, and retail. More recently, I've been focused on growing our DevOps practice, as well as helping companies determine the best path forward as far as cloud migration strategies go. So let's get to it. Here's a high-level view of my presentation. I want to start by re-baselining the definition of DevOps. It's become a bit of a buzzword in technology, as oftentimes happens in technology. You get these buzzwords and you actually lose the meaning of the actual term. So I want to kind of re-baseline our definition of DevOps, which will help steer us toward the measurement that I'm going to go after in section 2 of my presentation. So in section 2, and I'll give a little bit of a teaser here, we're going to be talking about objective measurements in DevOps to help drive our success metric. And I'll conclude my talk with a brief segment on the relationship between Agile and DevOps and how it really is a great pairing. At the conclusion of my presentation, I'll actually revisit this slide, but I wanted to bring it up right in the beginning. I want you to have 3 clear takeaways at the conclusion of this talk. I want you to be aware of the importance of measurement and monitoring in DevOps implementations, the importance of including DevOps in your Agile teams, and the importance of including experimentation in your DevOps implementation. Okay, and I'll explain a lot more about that one later. So let's get to it. What is DevOps? As I mentioned, DevOps has become a bit of a buzzword in technology. This happens a lot. The cloud, microservices. So when people hear DevOps, they think, like I mentioned before, Amazon goes to production multiple times per minute. But what is DevOps? At the highest level, DevOps is a set of practices and tools that are meant to reduce the time between development and deployment while maintaining confidence in the solution. So in short, speeding up the development to deployment cycle without sacrificing quality or confidence in your system. Okay, and ideally increasing both. So that's really the goal. So anything that does not work toward those 2 things, or at least one of those things, that's a clear metric for a failed DevOps implementation. So what else is DevOps? DevOps is automation. So repetitive tasks for, it says there, product management, development, QA, infrastructure deployment. They can all be automated to streamline your development to deployment process, which reduces that time to production while also increasing the reliability of the system. So number 2 there, confidence. Yeah, testing and monitoring built into these systems allows me to be more confident in each release of my software. This makes my software more predictable and reliable over time. DevOps is also a culture. It's a constantly evolving and improving practice. So you don't nail it out of the gate oftentimes in DevOps. So it's a mindset that your teams adopt, that we're always looking for ways to optimize, reduce waste in our development lifecycle. And DevOps is a journey. So that kind of bleeds into the last point there, but there's no single recipe for success with DevOps. So certain industries might have restrictions that don't allow them to deliver to production multiple times per minute. You may have a solution that requires a client's approval to deliver it. So there's not a one size fits all cookie cutter methodology here that anyone, I don't think, can present to you. But it's a journey, as I said. So at CA, we like to think about the journey of DevOps as a maturity scale. So this is really a generalization of that scale, but I just want to give the audience a view of some of the attributes that you might put into each one of these buckets or levels, if you will. So it might be a level 1 on the maturity scale if you have a monolith, you're doing a lot of manual deployments, there's a manual testing effort involved in each release. You might be a level 2 if you've identified some application segmentation that's available to you to make your releases a little bit more trim. You've identified shared services, shared components that can be utilized across your suite, and you've introduced some form of unit testing that protects your code base. Now, level 3 and level 4 are the more mature numbers, obviously on the scale here, but level 3s typically have fully adopted continuous integration, continuous delivery. So CI/CD, if you heard that term, CI/CD pipelines allow you to deliver, the goal being continuous deployment, but developer commit through deployment. So that's a pretty common term and a common goal for a lot of organizations these days. Level 4, we at CA view that as the most mature of organizations. They've identified that microservices architecture is kind of the way the technology is moving. And microservices, I mentioned that was kind of a buzzword, but all it is the thought that each service really has one job and it does that one job well. So that's really like the concept behind a microservice by definition. So what you gain there is you have microservices that have boundaries, okay, resulting in the ability to build and deploy these services independent of the greater solution. So other benefits of this approach, obviously, the ability to choose technologies at the service level. So instead of fitting your application or a service into a larger framework, let's choose the right technology for the right job. Let's choose the right technology for the job as opposed to one that fits in that larger framework. And so obviously test automation too is one way that the more mature organizations certify releases. If I have some automation that test automation that occurs after a release cycle, even if it's a smoke test, and I have a test automation that runs as a suite, maybe once a week to do the heavy duty testing, that gives me a high level degree of confidence that my system is up and reliable and healthy. Okay, so more mature organizations are kind of, those are two attributes of them. So this is again how we view things at CA. So DevOps components, what is DevOps made up of? So everyone's probably seen the Venn diagram with, you see the development circle and you see the operation circle and there's the intersection there, and that picture represents DevOps. And sometimes you might even see the third circle, it represents QA, quality assurance. But at CA, we like to look at things a little bit lower of a grain. This helps us identify areas more readily that we can eventually measure and find opportunities for improvement. Okay, so nothing wrong with the Venn diagram, but this is just one, maybe one level lower, one level finer grain here. And as you can see, some of these things could fit into buckets. So integration obviously could fit into either development or operations, or maybe that part of the intersection of the Venn diagram. Obviously, monitoring could be part of quality assurance and so forth. So in a nutshell here, I just like to look at things broken down at a slightly finer grain. And I'm going to walk you through just a few very specific real world examples to kind of help guide us here. But when we're talking about development, we're talking about obviously building the application, the architecture, the shared services part of that. We're talking about integration. We're talking about branch, if you're using Git, branching and merging strategies, the repository structure, whether you're using monorepo or polyrepo, those type of conversations. Deployment, obviously the actual release, any approval processes that are involved, any downtime that has to be communicated, and the app has to be brought back online, if you will. Monitoring, general application logging, system health checks, system availability checks. A lot of that stuff, if you're in the cloud, if you embrace cloud hosting platforms, a lot of that is available for you out of the box. But yeah, testing and quality assurance, unit testing at the code level, but then UI testing after the release, being able to protect and certify releases. That's that bucket. And infrastructure and operations. So some of the things you do with infrastructure obviously are provisioning infrastructure, securing your resources. And then as far as operations, one that we thought would be good to include is budgeting. Like, how much do these resources cost? So that's kind of a picture of the DevOps as we see it as CA. So now defining measurables. So thinking about that diagram, which I'll bring back up in a second here without the fancy animations, but there's really two measurables when we're talking about DevOps. You're talking speed and you're talking confidence. So confidence you gain by virtue. It's just a byproduct of success in DevOps implementations. So as you monitor these successes over time, you gain confidence in your system. As you add more reliability to the system, yeah, you're going to gain some confidence in your system. So speed, on the other hand, is 100% objective. We deliver software faster than we used to. So we can measure what the release cycle took previous to any changes. We can measure that after. We can measure the number of resources or people, rather, required to support a release. And we can measure that after we've implemented some DevOps enhancements. So speed, as I mentioned, is 100% objective, and that's the one that I want to focus on for this part of the talk. So I'll bring this diagram up just to kind of, look at it one more time before I walk through a few examples here. But, what can you think about? What can you measure? What can be measured objectively in some of these cases? Build failures, support tickets. These are objective numbers that we can measure over time. And as we experiment, and as we iterate over solutions in our DevOps practice, these are measurements that we can take note of, we can baseline, and we can monitor for improvements. And sometimes if you miss the mark on a DevOps implementation, you might see some pullbacks in some of those metrics. So that takes me to defining success. So as I mentioned, DevOps is an iterative process. So not often will a team nail it with their first attempt. So your organization isn't likely to be Amazon or Facebook on day one. In fact, those are two good examples. Amazon and Facebook both were monoliths originally. Okay, so over the course of several years and several top-notch development resources and spearheading some of the latest and greatest technology themselves, they obviously, Amazon being a cloud provider and Facebook coming up with languages that are widely adopted now, like React. So over time, they grew to be able to perform the way they do. Okay, so this slide is really just meant to represent the iterative process that is required in a DevOps practice. Again, you won't nail it necessarily on the first time every time. So what does that require? It requires you to plan. It requires you to build, deploy, and monitor, as the slide says here. But really, it is identifying opportunities for improvement, figuring out ways to objectively measure those scenarios, building and implementing the solution, and then monitoring that metric that you derived or set up during your planning cycle. So as you see these next few examples, I'll walk through the plan, build, deploy, monitor process as we've defined it. So I'll get right to it. Here's an example. So example one, Company A is a software development shop that is experiencing unreliable an unreliable integration process. Oftentimes, a developer committing code results in a broken build. So this delays deployments and even results in delays of other developers that pull down that bad code. Okay, so what we'd like to do here, there's opportunity for improvement. Obviously, we have broken builds, we have developers wasting time. So let's figure out how we can monitor that, plan for a solution, build it, deploy it, monitor it. So step one, yeah, we plan. So we measure the build failure percentage. Maybe that's one metric that we use. So what percentage of builds fail as a result of developer commits? Let's take a poll, or let's measure the repair time. So how much time are we wasting when developers pull down that broken code and have to repair it, or someone has to repair it before they can re-pull it down again? Just wasted time. So in this specific example, we might attempt to include some branch security as a part of the solution here. So what the branch security might entail is, okay, you need to build the software before it is accepted into the public branch. And again, I'm talking Git, so hopefully everybody's familiar with the Git terminology, the Git-based repo terminology. But if I have a branch, before I'm allowing a commit to that branch, I can certify that a build has successfully run using that code base before it's accepted. I might also include, as a branch security policy, I might also include the requirement that a software architect has to approve it and certify it. And maybe one additional peer reviewed, not only architect reviewed, but peer reviewed. Okay, so those are branch policies that I can implement here that hopefully will do the job. So I deploy that policy, and then I measure those two metrics I defined in the beginning, the build failure percentage and the repair time. So ideally in this scenario, you're not allowed to commit a broken build. So hopefully that repair time goes to zero, and hopefully that build failure percentage goes to zero. So in this case, you might have nailed it right up front, but there's other things you can do too. You can protect your build with unit tests, and you can go down the rabbit hole here with this one too. But in this case, my first iteration, I may have come close to nailing it. Okay, but you see how I had an objective measurement, build failure percentage, and repair time that I'm looking to monitor post deployment. So again, that's not an arbitrary number. Those are hard, objective numbers. So let's look at another example. So company B is a startup. They host and deploy their web application manually. There have been repeated issues with these deployments, and the release team has periodically failed and caused the team to roll back their release in the event that the configuration file was missed, or there was a file missed during the release cycle. Okay, so now, again, we have to think about objective measurements. So in this case, I'll bring it up for you. I might measure the failure percentage. Okay, so how often does the release management team or the QA team fail a release and cause us to have to roll back? What is maybe a ticket count? So maybe we have a client-facing application that our clients are able to submit support tickets. So maybe that's another metric that I might look at here. So failure percentage, requiring a rollback, and again, we can measure time there too, time wasted. But then also ticket count. So we may see an uptick of tickets after each release. So in this situation, since the issue appears to be mostly to do with the manual deployment effort, we might introduce the concept of a continuous delivery pipeline, and maybe the CI in front of that. So what is that going to give us? We go from that manual deployment to an automated one. So ideally, we have the repetitive steps and tasks that the person is doing manually for the release process. We're gonna now automate those. So there's hopefully no mishap available to happen here. So if configuration needs to happen every time, that's going to be in my pipeline. If copying files needs to be in there, that's going to be in the pipeline. So it gives you greater visibility to that process too, rather than having one person or multiple people responsible for that manual effort. So once I built that, I'm going to implement the pipeline, and I'm going to measure those metrics that I identified during the planning phase. So how often does my release failure result in a rollback post change, and how many tickets do I see immediately after a release? Okay. So this example can kind of piggyback off the last one a little bit, but I think I called it Company C and gave them a large firm title. But example 3 is a large firm that releases their web application every weekend during low usage hours. So typically, this is a 12 a.m. each Saturday night / Sunday morning. The release process is time intensive, as there are 2 QA resources that are required post-release to smoke test the software. Okay, so this one, probably a fairly common scenario for a lot of organizations. And I'll just bring up what we talked about, the plan, build, deploy, monitor sections. But let's measure the QA time required post-release. And a funny one might be let's measure our QA team or release teams sleep every Saturday night. Are they going from working from 4 hours every Saturday night? So what might be a viable solution here? So I'm going to take those measurements. I'm going to say, okay, we use an hour. Let's just use an hour. So 12 a.m. to 1 a.m. is an hour for every release, and that includes that QA certification step that needs to happen with our 2 resources. Okay, so that's the metric that we're going to be looking at here, and maybe the sleep one too. But the automated UI test might be a viable solution attempt to address this issue. Okay, so I may have a set of automated UI tests that run at the end of either a pipeline or a manual release that helps me gain confidence and certify that release. So I'm going to build that, I'll deploy it, and then we'll monitor post-release, post-implementation, what happens to that QA time, what happens to the number of QA resources or people that I need post-release, and how long does that process take? So DevOps is iterative, as I mentioned. Given this example, we may not nail it or even trust it the first few times. Okay, I still need John and Megan to do their QA thing, but we're gonna allow our automated test to run alongside of them. Okay, so after a few releases and we see that our QA time is kind of stagnant because we haven't made any changes, let's let John get some sleep on Saturday, and then we will continue to measure the QA time post-release and the number of hours of sleep John got that night. Ideally, over time, you end up trusting the system, and John and Megan are allowed to get their full night's sleep on Saturday and Sunday. Now, if you don't happen to nail it, maybe there's a few tests that you need to add on. Okay, maybe John and Megan did something they didn't really tell the other group members about to give them confidence so they can certify their release. The idea here is that we want to remove that wasted time, and we want to allow our employees to sleep a little bit more, which I'm sure they would be a little bit happier about. But again, back to the objective measurements. QA time post-release, we go from 12 a.m. to 1 a.m. A measure of success might be 12 a.m. and shoot for 12:30 or 12 to 12:15. So those are objective metrics that we're evaluating over time. We're comparing those post-release to determine if it was a successful attempt or not. Again, while also not sacrificing our confidence in that system. So, the DevOps experimentation. If you're willing to accept the current state of your DevOps implementation, you think things are as good as they're ever going to get, I think that's actually a measure of failure. So technology changes pretty fast, and sometimes that evolution happens pretty quick. So it's imperative that teams are constantly looking for ways to be more efficient with their time, and if you're thinking at the organization level, more efficient with your dollars. Okay, now I'm not advocating for a 90% experimentation rate with your DevOps life cycle, your DevOps practice, but I am arguing for some. I'm not going to put a percentage on it, but there should be some there. Okay, because current state, you can't accept that things are as good as they're ever going to get today. You're talking about DevOps. Okay. Now, I do have that note in bold there. So stability is just as important. So this isn't the wild, wild west where I'm just going to implement everything and just see what happens. It's important to identify metrics that you can monitor over time and give you higher degree of confidence over time. There's no zero to Facebook available. Okay. So stability is just as important as experimentation. So Agile without DevOps. As I mentioned, I'm an Agile proponent. Okay, so Agile and DevOps, they are different. So some would even argue that there's some conflict between the two. So Agile is about the people in the process, and people drive the change, and it's about building the right product. Okay, you're building toward the right product. Now, this isn't meant to be a critique of Agile at all, but there's a lot of subjectivity built in to the process. So story points assigned to user stories are an arbitrary measurement. That's why you can use t-shirt sizes. Just arbitrary. You're comparing relative sizes. Agile attempts to gain some objectivity with metrics like sprint velocity, but again, it's built on a subjective measurement. Okay, so on the other hand, DevOps is mostly objective. So how long does it take to release software to an environment before we made a change versus how long it takes now? How many hours did my QA team get to sleep last night? So Agile is about building the right product. The only real measurement of success in Agile is working product. Now, the success with DevOps, as I mentioned, really is determined by speed. Again, not speed for the sake of speed, speed with confidence. So I like to think of Agile without DevOps as Barry Bonds, and this is a baseball analogy, so hopefully we have a couple baseball fans out there, but Barry Bonds, pre-2000, is probably one of the top maybe 5 to 10 baseball players that ever played. So he was about, maybe 6 feet, 6'1", 175 pounds, a reliable, near 300 hitter, 35 home runs, 30 stolen bases. So just incredible player. And that's pre-2000. Now, post-2000, he became kind of like a superhero. He grew an inch somehow, put on maybe 30 to 40 pounds, and he became one of the most feared hitters of all time, slugging 73 home runs in a single year. And some say he had a little help, a performance enhancer, if you will. So to me, that's what DevOps is for Agile. DevOps is a performance enhancer for Agile. Now, the conflicts come in because of the people in the process on the Agile side, whereas DevOps is really technology driven and measurements drive the change versus people drive the change. But these two work hand in hand. So for Agile teams to be able to iterate efficiently and deliver working product at the end of every iteration, DevOps takes some of that burden off of those teams. So having a DevOps practice in place allows teams to iterate more effectively with more confidence. Communication barriers are removed, and that working software is delivered confidently at the end of each iteration. So Agile is pretty good on its own, maybe the best ever on its own, but in software development, DevOps gives it some juice. So thanks for listening to my presentation. As I mentioned, I wanted you to have the audience to have 3 clear takeaways as a result of this talk. One being the importance of the measurement and monitoring of DevOps implementations. One being the importance of including DevOps with your Agile teams as that performance enhancer, and the importance of experimentation in DevOps. Okay, so DevOps experimentation is important, but not for the sake of speed. So speed and confidence, just remember that. So thank you very much. Thanks for your time. Thanks for listening. And if there's any questions, I'll be available immediately after the talk. And there's my contact information. If you want to reach out, feel free. And thank you very much. Bye.